Have you ever stopped to think about how an AI experiences time? We usually just assume it's like us, but faster, right? A straight line from past to present to future. Well, today we're going to look at a completely different idea, a cognitive architecture where time isn't just a line, it's a programmable resource. And let me tell you, this isn't just a small tweak. It's a whole new way of thinking about intelligence itself. So let's just start with the big question right out of the gate. What if an AI could actually program its own time? I mean, imagine an intelligence that doesn't just live in the now and remember the past. Imagine one that can actively build, test, and even rewrite its own possible futures. Yeah, it's a pretty wild concept, so let's break down how something like this could even begin to work. Okay, so here's the fundamental shift. On the left, you've got traditional AI. For them, time is a one-way street. Simple, linear, can't go back. But on the right, this new idea, what's called a metatemporal architecture, sees time as more of a two-dimensional map, or a manifold. So instead of just one timeline, think of a whole landscape of possible timelines that the AI can explore and even change. And that jump from a single line to a whole map of time, that's the heart of this new paradigm. It gives an AI a much, much richer way to deal with time. It allows it to reason and plan and learn in ways that are just, well, they're completely out of reach for an AI stuck on that single linear path. So how does a mind like this actually function? Well, it's built on four separate layers. And the source material calls them temporal organisms, which I think is a brilliant way to put it. Each one has its own specific job, its own sense of time, and they all have to work together in this constant synchronized loop. So let's meet the crew. First up, you've got the perception layer. This is basically the system's senses, its eyes and ears on the world. It's always looking at a really short half-second slice of reality. It's not trying to understand everything, just capturing the immediate now and, really importantly, cleaning up that signal to filter out any noise. Okay, so that clean data from the perception layer flows straight to the inference layer. Think of this part as the systems detective. It takes all those little snapshots of reality and starts piecing them together, forming hypotheses about what's actually going on. And it's not just guessing, it's constantly tracking how confident it is in each theory as new information rolls in. Next up is my favorite layer, the projection layer. This is the AI's imagination. Based on what the detective, the inference layer, thinks is happening, this layer starts running simulations. It plays out all these different what-if scenarios, creating branching futures. But it's smart about it. It immediately cuts off the timelines that seem super unlikely or way too dangerous. And that brings us to the final piece of the puzzle, the evaluation layer. This is the coach. It's the critic. It looks back at what actually happened and at all those simulated futures and judges them. It calculates hard metrics, real data, and generates this incredibly detailed feedback that's designed to make the whole system better on the next go-around. So if you put it all together, you get this constant cognitive loop. The system perceives, it infers, it projects, and it evaluates. Perceive, infer, project, evaluate. Over and over. This feedback loop isn't just a feature, it is the engine that drives all of its learning and adaptation. Now, a system this complicated could easily turn into chaos, right? So you absolutely need rules. Very, very strict rules. This whole process is incredibly disciplined. The system uses something called temporal contracts to make sure information flows logically and cleanly. The goal here is what they call temporal hygiene. And these contracts have three main rules. First, phase-locked coupling. That's just a fancy way of saying cause has to come before effect, no exceptions. Second, time-to-live windows. This means old data automatically expires, so the system isn't making decisions based on stale information. And finally, back pressure mechanisms, which let the layers tell each other to speed up or slow down, keeping the whole operation perfectly in sync. Okay, so remember that feedback from the evaluation layer we talked about? In most systems we build, feedback is, just a suggestion, a helpful tip. But here it's something way more powerful. It's a temporal rewrite operator. Just let that phrase sink in for a second. The feedback from the past doesn't just suggest changes, it actively rewrites the future simulations. The system is literally editing its own potential futures based on past performance. It's learning by proactively rewriting time to avoid making the same mistake twice. Of course, when you have the power to simulate and rewrite time, you also run the risk of things going completely off the rails. You could get stuck in a bad logical loop or just lose sync, which is why the system needs a safety net. You can think of it as a kind of temporal immune system. And at the core of this immune system is one single number, a global consistency score. This score is basically the system's vital signs. It's constantly checking if the layers are in sync, if its beliefs about the world are drifting too far, and if the futures it's simulating are getting too risky. And if that health score drops too low, the system takes action. And these actions are just incredible. It can literally hit undo and roll back to a previously known good state. It can completely abandon a faulty timeline and fork a new, corrected one. It learns to ignore bad advice and can even tweak its own internal sense of timing and confidence. In other words, it can heal itself. So you have this incredibly formal, structured, self-healing system of thought. How does that compare to, well, us, to our own brains? It's a really fascinating contrast, and it shows just how different this kind of intelligence could be.
I mean, look at the difference. Our brains experience time as this continuous, flowing river. This AI sees it as a discrete, programmable grid. We learn through this slow, kind of messy biological process called neural plasticity. This AI has a literal rewrite time button. When we mess up, all we can do is remember not to do it again. This AI can just roll back time to before the mistake even happened. It's a formal, verifiable system, while our own minds are something we can really only study from the outside.
So, to wrap this all up, the main takeaway is this. The metatemporal idea isn't just a new algorithm or a faster chip. It's a proposal for a totally new way to think about thinking itself. It's about creating an intelligence that understands its own thought processes and has the tools to actively change and improve them on the fly. And that leaves us with one last, really big question to chew on. In programming, we use tools like get to version, branch, and fork our code. But what does it mean when an intelligence can do that to its own stream of consciousness? If it can version, fork, and literally rewrite its own timeline, what are the real limits to what a mind like that could do? What could it truly become?